So good afternoon to one and all present here. I hope everyone is doing well and is safe despite the pandemic. I am Yashodhara Bose, the event coordinator of Team ESTEEM and the moderator for today's seminar. On behalf of my team, I welcome you all to our fourth webinar as a part of the seminar series called Symposium. ESTEEM is the Solar Decathlon Society of Heriot University, and we participate in the SDME competition held in Dubai by building a smart home to tackle the problems of climate change. Our aim through Symposium is to elaborate our field of expertise and provide a learning platform about the different technologies, principles, and ideologies involved with STEAM. We'll be having a short practical learning interactive segment at the end of today's seminar where you can ask any questions related to the topic to our guest speakers today. And we'll be also recording the seminar. So if you want to see or refer to it later or show it to your friends, you can see a snippet of it on our social media platforms or ask us for the recording link via the email as well. Also, if everyone could just type in your email IDs at the chat box so we can share the certificates of participation for attending this educational seminar with you, which you can share on your LinkedIn, Instagram, or Facebook profile. And you can also tag us, that'd be great. So without further ado, I would like to welcome our guest speakers for the seminar today. That's Vinuki, Punara, and Mahnoor Irfan, who will be speaking on energy simulation and optimization through IES. Vinuki and Mahnoor are studying Bachelor's of Engineering honors in Architectural Engineering at the Dubai campus of Heriot University and have been promoted to Y4 and are the IES modelers for the Team STEAM. They'll be covering topics like energy efficiency and enhancement, design modifications, and all these cool, interesting topics that you're going to see coming up next. You can drop in any questions you might have in the chat box through the presentation, throughout the presentation, or raise your virtual hands up through the MS Teams feature, and I'm sure Vinuki and Mahnoor will be happy to answer them all. So over to you guys. Good luck. Let's have some fun today.
Hello, I'm
Thank you,
Vinuki.
Yashoda, for the introduction.
You can start,
And
Mahnoor.
as you know, I'm Mahnoor. And yeah, so welcome to our symposium. As Yashoda mentioned, it's on energy simulation and optimization through IES. So in this seminar, we'll be introducing energy, considering that you may all not have a background on energy. And we'll be informing you about it and also how IES is used to optimize and run simulations.
So let's start off with what is energy. It is the ability to do work and it is a necessity that exists in our everyday life. There are various forms of energy and it can be either renewable or non-renewable energy. It is important to choose our energy sources carefully and create awareness about it. Depleting resources. Limiting the use of non-renewable resources such as fossil fuels and reducing, recycling, and reusing is the most effective way to decrease energy consumption. Renewable energy sources can increase the well-being of humans mentally and physically with better air quality and thermal comfort. This reduces costs in the long term and gives optimum investment to the user. Energy can be reduced through decreasing wastage by using water and electricity responsibly and only buying necessary products. All these factors can in turn reduce global warming by limiting the energy needed to give comfort in our spaces. In order to know how much energy a system will use up beforehand, energy simulations are important. In Team ESTEEM, we use IES as a design tool to run those simulations. Energy modeling allows for correct system sizing and helps engineers to not waste valuable resources. This can lower construction and operating costs and cut down design risks. Energy efficiency standards such as the LEED and SIPSI can be practiced and gives optimum user satisfaction as systems such as air conditioning and heating can be ideal in terms of equipment life and users' thermal comfort. All these factors hence save time in designing and construction. In a typical household, what leads to high energy consumption? We have come up with a few sources that use up huge amounts of energy in our day-to-day life. For example, one of our bad habits is to charge our phones and tablets overnight when it's not necessary. Another is the use of air conditioning in the UAE winters, when we can simply opt for natural ventilation. How can we reduce these factors? using renewable sources such as solar, nuclear, wind energy, and Energy Star rated appliances, and sensors can drastically reduce energy consumption. So, what do you think can lower the energy consumption in a household? You can type into the chat box below. We'll give you some minutes to type it in.
So it could be any daily practice that you think you might be contributing and hopefully that you stop towards, but any idea would work. There's nothing wrong or correct. So
Yes.
yeah, they're all actually daily practices, hopefully. And
Hopefully, we follow all of it at home.
yeah, even laundry is a good example because we know how much batches we make at home usually, and then we end up not wasting a lot of water as well. But that's when the gray water system also comes into place, where you use the same water for maybe irrigation or maybe just an activity such as car wash or yeah. Yes, Nathan. All right, so thank you guys. So moving on. Now that you know about energy, let's move on to the energy and sustainability milestones. So starting off with in 1950s, when the first solar cell and first nuclear power plant was built, this was actually an introduction towards clean energy resources rather than just using fossil fuels. Then in 1990s, US Energy Star was introduced, which is actually a benchmark where in appliances such as any equipment that you buy, maybe it might be an oven, a microwave, any coffee maker, you would see the Energy Star rating. That would tell you how efficient it is, and that would actually help you reduce a lot of that would help you reduce electrical bills as well. Then in 2000s, LEED accreditation was introduced, which was actually used to assess a building's sustainability in aspects such as construction, retrofits, operations, and maintenance. Then by 2010, LEED was actually used in more than 140 countries, which actually became a benchmark, and we use it nowadays as well. And there are a lot of versions that keep coming up, updating it to the latest energy trends going on. And another achievement in 2010 was US and UK had more zero carbon sources producing energy than fossil fuels. So it was an introduction to any other source other than fossil fuels, such as coal. So now in the future, the global target is to reduce greenhouse gas emissions by 40% compared to 1990s level. This would actually help with the Paris Agreement goal, which is by the United Nations. And in 2050, UAE has targeted to increase clean energy from 25 to 50% and reduce carbon footprint by 70%, while UK promises to have net zero emissions, which means it's completely reliable on renewable resources and not using fossil fuels. This will actually help in limiting global warming from increasing to more than 1.5 degrees. All right, so now that we have a background on energy, let's introduce you guys to what IES is. IES is an analysis tool used for design and retrofit of buildings. The set of components used actually help you get the most accurate results in terms of lighting, energy, carbon, and equipment as well. So we'll start off with solar analysis. Solar analysis uses sun path and sun cast, which actually has the sun path of a location. It the solar radiation, the solar penetration, and also how much shading devices help in reducing solar gains. Solar gains are actually all the heat gains that you get from the sun. And this would actually, on IES, you can also show the shading of the surroundings of the building, which make it more realistic. And then you have geometry in IES, which is the base model. You start off with the basics like the building structure, the openings such as windows, doors, holes, and you can also put in your PV systems on it and other renewable technologies. And then you have airflow. So in airflow, you can also assign different zones which have similar activities. And airflow has two components. One is microflow, which analyzes the internal and external airflow using CFD. And the second one is macroflow, which uses the wind pressure and analyzes it through a thermal fluid solver. Then followed by using all of this, you can simulate results, which give you data based on load, the carbon, and the energy analysis of the building using different inputs such as thermal gains that you will be seeing later on. And then using the values, you get comfort analysis. So what you can do is once you finish simulating results, you can see how the air temperature is throughout the space, whether it's just like through, if it's suppose 25 degrees throughout the building, that might be too hot. In some spaces, you might need it to be cooler. So you can assess if users will be comfortable or not. And then lastly, you have HVAC systems. So you can use SIPC loads, ASHRAE loads, and Apache HVAC, which actually helps you model your systems such as mixed mode ventilation, then VAV systems and systems like you can find out if it's oversizing or undersizing your system using heat pumps. Like in ESTEEM, we're using heat pumps and chill sealing. So this might sound confusing right now, but you'll see on later on when we show the software. So yeah.
Now we will talk about the ESTEEM journey. In Team ESTEEM, IES was used from the start to predict the energy consumption in the house. In February, we started off with a basic HVAC model and general internal gains, where it gave us 78 megawatt hours annually. After modifying some internal gains and equipment, it decreased to 49 megawatt hours. In May, we modeled the HVAC system on Apache systems further, less accurate simulation, to get 16 megawatt hours. Currently, we have a 13 megawatt hour model that is accurately modeled on Apache HVAC with sensors, modified heat pumps, and logical time profiles. But we are still in the progress of getting accurate simulation values, so it might change later on.
So we did a quick performance gap analysis to see how accurate IES is as a software. And we noticed that there's only a difference of 2 to 3 kilowatt hours between the manual calculations and IES software. And that could be because IES considers the actual real-time weather data and also the actual solar gains, while maybe in manual calculation, it might be more generic than IES. And to show you ESTEEM's breakdown compared to a house in Middle East, you can see that in ESTEEM, there's only 20% contribution from space cooling, whereas in a typical house, it's 50%. So that shows that the energy used for space cooling is much lower in our house. And the lighting is 3% instead of it being 11%. This is because we're using the most efficient lighting system with sensors as well. And you can also notice that we have 42% contribution from renewable technology that you wouldn't have in a regular house. And that would save a lot of energy because of on-site generation. And yeah, so that's the performance gap and how IES works. And now we'll do a quick demo of how you can also optimize with just basic input. So we have two models. One is the base model, and that Vinuki will be explaining. And then we'll move on to the optimized model, which shows you the basic input that we can just change, and you can also try it out.
Here is the base model that we have created beforehand. In AP Locate, you can change the location of your model. Currently, it is set to London, UK. If you go to Model Viewer, the full model can be seen in a render view. Here, the windows are located in the south and west sides. The sun path diagram shows that the highest solar radiation comes onto the south and west. So this is our full model. The model was created by clicking on extruded shape, where you can type in the plane, the height, and the width. The roof can be generated by clicking on generate roofs, where the slope can be typed into. The windows were created using this, where the base height, the width, and the heights can be typed in. The doors were created using this, the same way as the window. Holes can be created inside the space when there is adjoining spaces. And then onto the building template manager. It takes a few minutes to load. So here are the the templates that will be used in our model. You can add in construction materials, macro flow, thermal properties, and lighting properties. Onto the construction, the roof and the wall have no insulation, hence heat can be um, transferred inside and transferred outside faster. For the window, a single pane glass is used, as seen here. Hence, there will be high energy transfer through the glass too. And then onto the thermal template. As you can see here, the HVAC model was modeled in the Apache system instead of Apache HVAC, which is less accurate. The heating and cooling profiles are set to be on continuously, and the DHW consumption is set to be 60, which is higher than usual. For the internal gains, the lighting is set to have incandescent light bulbs, which is the highest energy used light bulbs, and it has 1440 watts. There are 10 people modeled in this house, and each person is gonna give away 90 watts. There's one computer located also, and we have put a typical value of 80 watts. As you can see here, all the internal gains are set to be on continuously, so it can give the maximum heat loss. And then onto Apache, where you can assign the templates over here, the thermal templates, general templates, and the construction templates. Here you can simulate after adding everything in. We have simulated it beforehand, where you can see the results in Vista Pro. So the total energy we got was 89.9, as you can see here, which is really high for a space of a space that is this size. And in loads, if you go to room heating plant sensible loads, which is the heating loads, as UK uses heating the most, you can see here that the highest peak is 9.4 kilowatts in December, which is a lot higher than the usual. Now Mahnoor will show you the optimized model of this version.
All right, so you guys can type in questions as well if it seems confusing for now, just so that after this, we can help you figure it out as well. So we'll go to the geometry to show the changes we made in the optimized model. Starting from the roof itself, it is much flatter than the previous one because apparently whenever we model roofs, the flatter the roof, the less thermal gains it has. Then moving on to the solar panels, we placed 4 solar panels to show how renewable technology works on IES as well. And considering UK's sun path, you can see that there's more solar radiation towards the southeast, which is southwest, sorry, which is why the solar panels are placed there. And the glazings have been moved from southwest to northeast because we would want to avoid the thermal gains and solar radiation as well, and minimize thermal gains as much as we can, solar thermal gains. So that's from the geometry bit that we changed. And we'll move on to the construction. And it takes a while to load. All right, so in construction, Vinuki mentioned earlier that there was no insulation and we used default values. But to show you the importance of insulation within materials, for roof and external, we added insulation layers of 100 millimeters. And you could see that earlier the U value, which was 2.4, is now 0.23. And for the external wall, it was 1.68, that is changed to 0.93. This means that the thermal resistivity has increased and less heat would pass through, less colder heat would pass through. And for the external window, earlier it was just a single pane, but in this, we made a double glazing with krypton as a gas filled within the cavity. Krypton helps to slow down the thermal conductivity. So the U value of the window was quite high. It was 5.6 before, and now it changed to 1.34 just by changing the composition and adding a gas to it. So after changing the construction database, we'll move on to the last bit, which is the thermal. So when you go to the thermal template, earlier you had seen that it was on continuously for all the systems, right? But now we had created time profiles to show you how realistically you're supposed to model. And you could see that it's at 0.5 capacity at sometimes, and otherwise it's full. And you can tweak it according to the building space and timings. And you could also see that for the domestic hot water, it was 60 liters per hour, but now we changed it to 45 using SIPSI guides for an energy efficient building. And we have also assigned it another time profile. And now to the internal gains, which is the most important part as well. We're using LED lighting, which is the most energy efficient source. And before, the previous lighting system was around 1000 watts, but this has lowered down to 240 watts. And sorry, I think, yeah. And then for the people, we had used SIPSI guides again, which reduced the sensible gain per person to 80 watts per hour per person. And the last bit, which is the computer, we're using an Energy Star rating that we mentioned, and the computer just provides sensible gain of 55 watts, which is much lower than a normal computer that you would use. So after adding the internal gains, and we have the time profile. So as you can see that Vinuki is showing, there are different time profiles added. And even for the water and equipment, you wouldn't have it on throughout the day because again, that's just wasting and not in use. And you just tweak it according to the consumption. So yeah, we made the time profile changes, added the internal gains, the construction, and then we ran a simulation again. And you could see that the total energy has now become 24 megawatt hour, and the heating load, as it's UK, it has also decreased. Keep showing. Yeah, so the peak heating load in December has become 7 kilowatts, and that's the difference there. You would see the difference on the last slide as well. And now Vinuki would show how we're using that in ESTEEM and how our current ESTEEM model looks using Apache HVAC.
Let me just open it. So here's our current ESTEEM model. If you go to model viewer, you can see all the components in our model. You can see the solar panels, the solar thermal panels, the wind catcher, a small courtyard, the windows and the doors, and also the shadings around it. If you go to the building templates, we will show you the thermal templates of our ESTEEM model. Takes a while to load. Yeah, so we used Apache HVAC to make it more accurate instead of Apache systems. And the set point for heating is 23. As you can see, it's different from the UK set point as heating is not used in the UAE. For internal gains, we have added various internal gains, and we have also added various variation profiles to best represent the competition time. And then our result, the Apache HVAC system is shown here. Here we have the sensors. Here we have our rooms, dining room, kitchen, corridors. Here we have our cooling coils and the heating coils. And then the supply fan, the extract fan, and then the heat exchanger. We're still going through the HVAC model to make it as accurate as possible. And now we will show our last slide where we will conclude our symposium.
All right, so Habiba asked if it's cost efficient or not. Um, in the long run, it definitely is cost efficient, and you will see because it's more sustainable compared to other systems, and your as an end user, your electricity bill is going to reduce as well. So it's always a benefit. I'm just trying to load the last slide. Sorry. Okay. So to basically summarize how important IES and the inputs we just discussed are. So starting off with orientation, you noticed how putting the glazing on south and north had a huge impact because of the solar radiation, and adding shading devices as well. We had it shading on the glazing, and using renewable systems, you saw that 42% contribution in the ESTEEM model has reduced the energy much more. And in construction database, we showed how U value has an impact because it shows how much thermal conductivity a material has. And followed by heat gains of how efficient the equipment is. You saw that we used Energy Star rated appliances, and also LED lighting. And the last bit is a system set points and time profiles. Before it was on continuously, but after we changed it to accurate and realistic timing profiles, it reduced the energy consumption by a lot. So to summarize it, basically the base model had a total energy of 90 megawatt hours, which then was changed to 24 megawatt hours just by the input we showed you. And the peak heating load started from 9.4 kilowatt, and that changed to 7 kilowatt, sorry. And this was all done by just the input. And the more you go into detail with the software using Apache HVAC, the better the results would be for sure. So that concludes our seminar, and thank you for joining us. We're open to questions now.
Thank you.
And also answering Nathan's question about how we're using 2021, I just want to say there's a backstory and we're still using the trial version.
Yeah.
That was great. Like it was indeed a very descriptive and informative presentation. I was really looking forward to the seminar to learn about integrated environmental solutions in the virtual environment, and just such an interesting topic. So thank you, Vinuki and Mahnoor, for that. So moving on to the interactive session now, we had received a couple of questions in the registration forms, which I would like to ask Vinuki and Mahnoor at the same time. Anyone, whoever is attending right now, if you have any questions or queries about IES or the seminar you just saw, the presentation, just drop in your questions on the chat box or raise your virtual hands and unmute yourself and ask the questions. And Vinuki and Mahnoor will answer them soon. So I'll start with one of the questions that I had got. So from a scale of 1 to 10, how user friendly is IES? Is one question that we received in the form.
Okay, so from personal experience, I would say a 7 because of the user interface. It's pretty like you can know what software, what model IIT is just by the name of it, what geometry is. But the problem that I have faced would be in terms of Apache HVAC, which is much more detailed. But Nathan has Nathan said minus 100, which I think is he's had a really bad experience. But I would say that IES has helped me understand energy much more than I would have learned through theory. So yeah, that's my
That's
take.
cool. Yep. I see another question here with Scott. So, what did you find made the greatest impact on the energy use in our house?
I think it would probably be the internal gains and the construction materials. Or what do you think, Manu?
Yeah, honestly, once when we were running the simulations over these months, the main part was internal gains on the time profiles, because the more accurately we plotted the time profiles according to the competition hours, it went down from 76 in February to latest at 13 megawatt hours. So yeah.
That's great. Okay, we have another question here. Could you please tell me the second component of airflow? I missed out. I mean, Habiba missed out, so you could just tell that. Yeah.
Oh yeah, so the
Okay.
second one, I think that would be macro flow. Macro flow uses the wind pressure, which is basically natural ventilation, and how the natural ventilation works throughout the house without using air conditioning, and yeah, it just models it. So yeah.
And shows the values in liters per second.
Yeah, and can I just add, like in middle of the questions, like I just love the coordination between Vinuki and Manur. Like Vinuki was doing this screen sharing and all the mouse pointer, but Manur was on point, saying the same things at the same time. So that was just like amazing coordination, guys. Okay,
Thank
another
you.
question here. How to get the IES tool and is it free?
Yeah, you can get the IES software through the official website. It is free for 30 days. After that, you have to buy it. But for students, you would have to buy it. And uh, For us, we're using the free software still.
Okay, cool. Guys, you can drop in more questions if you have. So until then, I have another one. What all attributes does the IES tool cover? Like, I'm sure you already covered half the points in your presentation, but would you like to shine some light more on the other attributes that IES tool covers?
Okay, yes, I would just go on that slide. So it's mainly it's all of this at once. It depends on how you actually model it. So maybe you could just check out how the solar works, or you could add in the internal gains and see how that works as a whole. But the main attributes of IES would be how energy consumption is, and just a small detail that you wouldn't really get from manual calculations or another software. So it has comfort analysis, and the main part of IES I would say is the HVAC system to know how much the building services contribute. So yeah, I hope that answers the question as well.
Yes, definitely. So Rushan has asked a question. What are the limitations of IES? That's the same question we've received in the form as well. So bang on, Rushan. So any drawbacks or limitations of IES?
The limitations would be the geometry, where you can't model it like like in Revit or AutoCAD, and you can't move it around. So that's a big limitation.
Yeah, and I would like to add on to that. Another limitation that we faced personally was Apache HVAC on how, suppose you might think you're modeling it right, but you always have to cross check to make sure the systems are right, the sensors are right, because that's the technical bit of it, but that's the problem that's one of the limitations I would say. You need to know more of the technical side for it.
Right, correct. Okay, Nathan has asked, an IES simulation could also lead to a performance gap when compared to the real house. How have we tried to tackle that problem?
Um, do you mean in terms, Nathan, do you mean in terms of esteem, or
Yes,
do you
yes,
mean generally
esteem.
as I? Okay, so I think I would give an example of how we've been in touch with renewables and services at the same time. Roshane knows how much we've been annoying her with values as well to make it as accurate as possible, and how we've been confirming on the heat the same values, the same exact heating capacity, cooling capacity, and that would avoid performance gap as well because we started off the heat pump of 50, which was inaccurate and it was a default value on Apache. And that's when the performance gap part came in, and we try to go through every technical data sheet and make it as accurate as possible to avoid the performance gap. I hope that didn't confuse you.
I'm sure Nathan will be happy with the answer. Yeah. I think Scott asked a question, but Vinuki's already answered that. So the last question that I've got here is, which is the best software available to model and assess the energy at a neighborhood or area level?
I think from our experience, as we mainly use IES, IES is the best energy modeling software, but there might be better ones out there that we don't know of.
With
Okay,
that being
no
said, I
problem.
hope IES sponsors us as well. I know they're sponsoring Team is Team, but IES is the best software.
Yes.
Perfect. Um, I think there are no more questions. I can't see anything else in the chat box, and all the questions from the registration forms are covered. So, anything else, Mahnoor and Vinuki, if you want to share any advice to the people who are attending here, if they want to try IES, how should they go about it, or something? Anything you would like to share?
For IES, there are tutorials in the official website for free, some of them. So you can go through that, or you can ask us any questions if you have.
Yeah. And Mahnoor, if you want to say anything.
Habib, the best hack is knowing that you can copy paste the geometry on the other orientation, which I don't know if you guys would understand right now, but it means a lot to us. And that's the main part. And yeah, any question that you guys have about the software in any way, even if it's the most generic, because background. I mean, sustainability knowledge or any energy knowledge. So you can ask us anytime. Hopefully, we can help. So yeah.
Yes, definitely. With this knowledge that you already have, I think you can help anyone right now. So thank you. That was really very helpful, Vinuki and Mahnoor. I mean, it takes a lot of time and effort to do something right the first time, especially in big construction tasks where one mistake can put life and money at risk. But I'm sure after attending this seminar, a lot of us have learned how to monitor the efficiency in doing these difficult yet important tasks. So thank you again for that. I would also like to thank all the attendees for taking some time out to come today. So, if everyone could just turn on their cameras, I would like to take a screenshot for our social media. That would be great. So, guys, just turn on your cameras. Don't feel shy. And my laptop is hanging, but I'm going to try to take a screenshot now.
I would like to call out Sana and Nathan because they always have their cameras on for our calls, and this is the first time I have my camera on, so they owe it to me.
Manu, can you stop sharing the screen so that I can get everyone on the same
Oh
screen, if
yeah.
that's okay? Yeah. Yay! Everyone else, if you could just turn on your cameras, that would be nice. Hi, Riz, Scott, Sana, Rushen. Yay! So smiling faces. I love smiling faces. Okay, I've clicked my print screen a lot of times. I hope the screenshots have been taken. Otherwise, I don't know. My laptop is just always so hanging all the time. But thank you guys for turning on your cameras. Thank you so much again for attending. Also, our crowdfunding page is live now. So if you'd like to donate any amount to help our team build the smart home, we'll be grateful to you. If you're in Edinburgh, you can also book a slot via Eventbrite to visit our prototype at the campus. And if you're interested to learn about CFD, computational fluid dynamics, attend our next technical symposium, which I hope is going to be held soon. And kindly follow us on Instagram, Facebook, LinkedIn, and Twitter to get updates on the upcoming seminars and details about ESTEEM. We are Team ESTEEM. We hope you enjoyed today's seminar, and I hope you get to enjoy the summer with the COVID relaxations. So take care, and thank you all once again for joining. And thank you, Mahnoor Vinuki. Thank you so much.
Thank you guys. Thank you everyone for joining. Means a
Yeah,
lot. Thank
thank
you.
you. Thank you to everyone who joined today.
Okay,
Take
see
care.
you guys. Bye.
Bye.